Today, we're diving into something that's like the absolute backbone of a ton of modern software. We're talking about the 5 pillars of object-oriented programming. All right, let's play a little game. Imagine for a second that you're building a whole world inside your computer. You know, a world filled with cars, people, maybe even bank accounts. The big question is, how do you get all that stuff to act the way it's supposed to, just like in the real world? Well, that's where this amazing concept called object-oriented programming, or OOP for short, comes into play. It's basically a super smart way to organize our code by modeling it after, well, real-world things. We call them objects. And trust me, it makes building those digital worlds a whole lot more logical and frankly easier. Okay, so how does this actually work? How do we take the real world and translate it into code? It all starts with a couple of key ideas: having a blueprint to build from, and a vault to keep everything safe and sound. All right, let's dive right into that blueprint and that vault. These are our first 2 pillars. First up, we've got what is, without a doubt, the cornerstone of OOP: classes and objects. Think of a class as the blueprint. It's the design, the schematic, maybe even the recipe for something. The object, on the other hand, is the real thing you build from that blueprint. So the idea of a car is the class. The actual car sitting in your driveway, that's the object. And this analogy is just perfect for it, right? You have one single car design, that's your class, and from that one design, you can crank out thousands of actual individual cars. Those are your objects. Every car is its own thing, but they all come from that same fundamental blueprint. Okay, next up is encapsulation. And if classes and objects are the blueprint, think of this as our digital vault. The whole point here is protection. It's about bundling up your important data with the tools that can change that data, and then putting a protective bubble around it to keep it safe from outside meddling. It's kind of like a bank, right? You can't just stroll into the back room and start changing the numbers on your account balance. No way. You have to go through the teller at the window. That's the secure, approved way to do things. In our code, that teller is what we call a public method. It's the only safe way to mess with the private data that's locked up tight inside our object. Okay, so now we know how to build our objects and how to protect them. The next logical step is to see how these objects relate to each other. And that leads us to some really cool ideas that are kind of like family trees and shapeshifting. And that brings us to inheritance. This one is all about working smarter, not harder. I mean, why build every single new thing from scratch? With inheritance, you can create a new child class that just, well, inherits all the features and abilities from an existing parent class. The family tree analogy really works here. You know how you inherit traits like your eye color from your parents? It's the same idea. You could have a general vehicle class that has basic things like speed. Then, a more specific car class can inherit that speed trait and then add its own unique stuff like number of doors. It becomes a specialized version of its parent. All right, next up is a word that sounds super complicated, but the idea behind it is actually beautiful: polymorphism. It literally just means many forms, and it's this awesome ability to have one single command do different things depending on the situation. Just look at this. The command is exactly the same: start, function. But think about it. When you tell a car object to start, you hear an engine roar to life. But when you tell a bike object to start, you hear a chain clicking into place. See? Same word, same command, but it results in a totally different, totally appropriate action for each object. That right there is the magic of polymorphism. And that brings us to our 5th and final pillar. This one is all about taming complexity by hiding away all the messy, complicated stuff. And that pillar is called abstraction. The entire goal here is to make things simple. It's about showing only what's necessary on the outside, while all the complicated inner workings are hidden from view. Basically, you're creating a simple, clean interface for a really complex machine. Let's go back to the car example. When you drive, what do you actually use? A steering wheel, some pedals, maybe a gear stick, a really simple dashboard, right? You absolutely do not need to be a mechanic who understands internal combustion just to drive to the store. That dashboard, that simple interface, that is perfect abstraction. Okay, I know what some of you are probably thinking right now. Hang on a second. Isn't that just encapsulation? And you know what? That is an excellent question. It's a common point of confusion, and getting the difference is super important. So here's the key difference. Abstraction is all not hiding complexity. Its focus is on the outside view, making things easy for the user. Encapsulation is about hiding data. Its focus is on the inside view, protecting the internal state from being messed with. So, back to our car. The simple dashboard you use, that's abstraction. The sealed engine block you're not supposed to open, that's encapsulation. All right, let's wrap this all up. Let's bring it all home. What's the big picture here with these 5 pillars? And here it is, the whole shebang. We've got class and object, our blueprint and the real thing. We've got encapsulation, which is all about keeping data safe, inheritance for reusing and extending what we've already built, polymorphism, letting one action have many forms, and finally, abstraction, which is all about showing only what's needed. When you put them all together, you get a powerful way to build software that's strong, flexible, and just plain easier to wrap your head around. So there you have it, a quick tour of the 5 pillars of OOP. It's kind of cool, right? You now have the mental toolkit that programmers use every single day to create all this amazing software. So I'll just leave you with this one question to chew on. Now that you know the rules, what's the first real-world object you'd want to build?